Okie dokie, in this video we're going to start the 12.3 WebAssign. Start with number 1. Find the critical point of the function and use the second derivative test to classify the nature of this point. So the idea is we want to find fx and fy, and we're finding the ordered pair that makes both fx and fy equal to 0. So starting with fx, the derivative of this with respect to x would be negative 10x. The derivative of f with respect to y would be negative 4y. So the derivative of the y term. Now, we want to find the x and y value that make both fx and fy simultaneously equal to 0. X equals 0 would make fx equal to 0, and y equal to 0 would make fy equal to 0. So the ordered pair that makes both fx and fy equal to 0 are 0, 0, or is 0, 0. Excuse me. Now, we use the second derivative test. The second derivative test is to find fxx, fxy, and fyy. That's the first part of it. So, looking at fx and taking the derivative with respect to x, the derivative of negative 10x with respect to x is negative 10. Looking at fx and taking its derivative with respect to y, negative 10x with respect to y would just be 0 because there's no y term in negative 10x. Now, to find fyy, we look at fy and we take its derivative with respect to y, so negative 4. Now, with these second derivative values, if we had a place to plug in x and y, we would plug in our ordered pair of 0, 0. But we do not. So we can just calculate what is known as d. We want to find the d value, which is found by doing fxx times fyy minus fxy squared. So we are going to do negative 10 times negative 4 minus 0 squared. Negative 10 times negative 4 is a positive 40. So positive, the sign of d, is all we are concerned with. Now, when d is positive, let's talk criteria. If d is positive, you have two possibilities. You could either have a min or you could have a max. That's dependent on the fxx value also being positive or being negative. And so, in this case, since d was positive, right here, and since fxx was negative, then that means we should have a max, because d was positive and fxx was negative. So we should have a max at 0, 0. Okay? That's the classification. Let's talk other classifications. When d is negative, it's neither a max nor a min. It's automatically a saddle point at whatever critical point you did the second derivative test for. And then if you happen to get d equals 0, we say that's inconclusive. It doesn't really tell us anything. There's no, nothing we can say about that critical point, okay? So that's the criteria. That's the second derivative test. Now, to actually determine what that max value is, we just plug in 0, 0 to the function here. So the max value would just be 3 minus 0 minus 0, so that would just be 3. And DNE for minimum, because there was no minimum. Okay, that was number 1. Hope that makes sense. Let's keep it going. Number 2, let's at least do 2 and 3 in this video as well. It's going to be a lot of parts for this WebAssign. Once again, critical point of the function. I'm going to write fx and fy up here. I'll do it like this time. Try to be a little more strategic. So fx, the derivative of this with respect to x would be 2x minus xy. So x right here goes to 1, so minus 1, but the y was attached to the x. So it stays attached to the derivative of x, which is just 1. So we have minus 1y. That's the derivative. This is all the derivative with respect to x. Now, restarting, looking at f, taking its derivative with respect to y to find fy, x squared goes to 0, minus x times y goes to minus x times 1. So minus x. And then plus y squared goes to plus 2y. So now we have fx and fy. So let's find our zeros. We set fx equal to 0, so I'll just set 2x minus y equal to 0. I'll just do it up here. And what we can do is add y to the other side. So we get 2x equals y. Then let's do the same thing over here for fy. We're going to set fy equal to 0. And we will get 2y equals x. So you have an option. You can just sub one of these into the other and solve for whatever. So just plug 2x in place of the y over here or vice versa. It doesn't really matter. What you'll find is that if I plug in the 2x in place of this y over here, we get, excuse me, 2x equals x, or sorry, 2 times 2x equals x, which means 4x equals x. And so you wonder, how could that be? Well, if you subtract x on both sides, you have 3x equals 0, which means x must equal 0. So then you plug that back into either of these, this one or that one over there, it doesn't matter. And you find that y must also equal 0. So if you plugged it in there, it'd probably be a little more clear. So it'd be 2 times 0 equals y. So in other words, y just equals 0. So our critical points aren't always 0 and 0, but it seems like that's how it's turning out for these first, couple of easy ones. Now, we're going to do the second derivative test, finding fxx, fxy, and fyy. And then we're going to calculate d, find the sine of d, and classify. fxx is the derivative of fx with respect to x. So the derivative of the x term is just 2. When we look at fx and we find the derivative with respect to y, the y term is just going to give us -1. Now fyy is the derivative of fy with respect to y, so that is just 2. Now we calculate d. We do fxx, 2, times fyy, 2, minus fxy, -1, squared. Be very careful with parentheses and squaring and signs and whatever. But regardless, this will give us 4 minus 1, which is still positive. So d is positive. fxx was a positive 2. So when d and fxx are both positive, that leads to a minimum. So we have a minimum at 0, 0. To find what that minimum is, we are going to plug in 0, 0 to the function. When we plug in 0 and 0 for x and y, we get 0 minus 0 plus 0 plus 3. In this case, 3 is our minimum, and the max does not exist. Let's do one more. Number 3. You want to be a scholar this semester? Go to payhip.com/VTMathTutor and get the Scholar Pack. There you'll find videos for every single chapter review quiz you need to complete this semester. These are perfect for studying for your tests. They're actually broken up by tests here. Test 1, what do you need? Chapter 2 review quiz? Perfect. What do you need? Problem 7, let's go to problem 7. Oh, what do you need? Problem 10, let's go to problem 10. Look at that. Everything you need for every single test. This is perfect review material, perfect study, practice, whatever material. Everything you need right here, studying for exams in the Scholar Pack. Go to payhip.com/VTMathTutor and become a scholar today. Bye.